Look at this problem. You have a set of discrete uniform random variables x1 through xn. So the probability of xi equal to k is 1 over n. We'll do two problems. Usually, so the problem is you don't know what's the n. We want a best estimator for n. So as I was saying, if you look at the taxis in the city and assuming they are numbered 1 through n, you stand somewhere and you look at, when you look at the taxi numbers on n of them, you are actually reading the manufacturing number, assuming they are in serial or number orders. So if you observe a few of them, question is how do you find out the a best estimator for the total number of taxis in the city or total number of trains, the goods trains running around, or a car manufacturer, or same thing with guns, right? Guns have a serial number, but if you can convert the serial number into the actual production number, somebody who knows that table, knowing the serial number, can figure out how many guns have been manufactured, etc., at least in sort of principle, right? So once you do the decoding, you have these numbers, which are observations from here. So we are trying to find out a best estimator for n and best estimator for 1 over n. 1 over n, why? Don't ask me that. But knowing this is not the same as this. So, but this is a little easier, so let me start with this first. So anyway, T is the sufficient statistics for so anybody? So remember, we have Rao-Blackwell theorem in our hand. So all we need is just a sloppy estimator for 1 over n. So looking at this, anybody has any clue? We just need, the expected value of something needs to be 1 over n. What can we start with? Especially considering the previous, we can take clues from the previous example. What? Yeah, so you observe a sample. So what is the estimator? Why that's the estimator. What do you want to define?
1 for x1 equal to 1, I guess.
Remember, x1 is whatever it is, right? x1 is going to be a number 223. Then x1 is 2. But you want to define what? Y is 1 when? I'll take what you said. Actually, what you said will turn out to be 1. Suppose we... Anybody? What is the expected value of y? Anyone? So this may not, I'm saying all it says is that if x1 happens to, not 0, if x1 happens to be 1, remember x1 only goes from 1 through n. So if x1 happens to be 1, then we'll assign y to be 1. So if x1 is 223, y will be 0. So that's perfectly fine. What's the expected value of y? No? Yeah, okay, so this is, the good thing is this is 1 multiplied by probability of y equal to 1, which is probability of x1 equal to 1, which is 1 over n. So we have an unbiased estimator for 1 over n. So now, so the best estimator is going to be, I'll write it as T naught, is expected value of y given t. So y only takes one value, so y is 1 multiplied by probability of y equal to 1 given max of xi equal to t. So this we need to compute. So this is the same as, look at here, y is the same as x1 equal to 1 max of condition known, max of x1 etc. xn equal to t. So this, you could write this as probability of x1 equal to 1 comma max of x1 etc. xn equal to t divided by probability of maximum x1 etc. xn equal to t, right? Just from so let me define z to be maximum of x1, x2, etc., xn. So as I said, this is true, right? Because it is discrete random variables, t jumps 1, 2, 3, etc. Z less than or equal to t is the same as z equal to t and z less than or equal to t minus 1. And these are mutually exclusive events. So probability of this is this probability minus this probability. I hope you see that. So probability of max z equal to t is the same as probability of z less than or equal to t minus probability of z less than or equal to t minus 1. So what we are interested, which is maximum of x1, etc., xn equal to t is probability of maximum x1, etc., xn less than or equal to t minus probability of max x1, x2, etc., xn less than or equal to t minus 1. So if maximum is less than or equal to t, then each one is less than or equal to t, right? So, and each of them are independent, so this becomes the product. So the left side becomes product of probability of xi less than or equal to t, I equal to 1 through n, minus product of probability of xi less than or equal to t minus 1, I equal to 1 through t. So each of them is of the form, remember, look at here. So if this is t here, what is the probability that xi is less than or equal to t? Anybody? 1 plus n, 1 plus n, 1 plus n, etc. So what is it? T over n, right? So I hope you see that this is t over n to the power n minus t minus 1. Okay, so we got that. So look here. This I can simplify one more step. Here, look at here. Here it says x1 is 1 and maximum of x1, x2, etc., xn equal to t. So this I can, x1 is 1. So this is, look at the numerator. This is the same as x1 equal to 1 and maximum of x2 through xn. Because if x1 is 1, then the maximum of x2, etc., xn equal to t divided by maximum of x1, etc., xn. If you want, you can write it will exactly come out to be, you could put here as two conditions. When t is 1 and t is greater than 1. When t is 1, if maximum is 1, then all of them are 1. If t is greater than 1, then this is true, what you said is true. But in both the cases, the result will exactly turn out to be the same. Now look here, you can write one more line. These two random variables are independent, so this is the product now. So maybe I'll just keep writing here. So this is going to be, so I can just substitute it here. Here you have, the denominator is what we have. The numerator will be exactly the same as this. What's the difference between numerator? You only have, here you have n random variables. Here you have n minus 1 random variable. So I hope you see this. So this is 1 over n. And this is t to the power yes. So I'll write it here. So this is t to the power n minus 1 minus t minus 1 to the power I mean, obviously you're not going to guess this. So this is the best estimator for 1 over n. So maybe since I am here, let me also do the other part, best estimator for n. Remember, I did this part first because it was. So this is done in detail in the notes, so I'll sort of sketch it. Any questions here? So yeah, you have a question? You raised your hand. So look here. So for example, if you can do this, I mean, so if these observations are 2, 10, 65, whatever, 132, then you find the t is the maximum of the, you find the maximum and then see what is the n. If n is 10, then you put these values here and that will give you the best estimator for 1 over n. Flipping that is not the best estimator for n. That's the moral of the story. So if you want your task, if you want to come, what is the expected value of t naught? Anybody? You don't know? Huh? That's guaranteed by theorem. But what you may want to do is what's the variance of t naught. So I'm going to leave it to you to compute, right? So this is your t naught, and the expected value of t naught is 1 over n. And what is guaranteed is that there is no other unbiased estimator better than this in terms of variance. So that's guaranteed. So let me do the first part. So remember again, from here, for n or 1 over n, this is still the, I hope you see that, right? This is still the Tx. Sufficient statistics is still maximum of x1 through xn. And we have the density function of this maximum here. So let me look at this problem. So now we are on to remember, any of these random variables goes through 1 through n. So the maximum also goes through 1, 2, etc. up to n. So this is the density function that we derived here. So I'm just going to erase all this stuff because we are done with this problem. So the other one, I call it a taxi problem for the reason I explained to you. So we want so see whether such a trick will work. Can you give me an unbiased estimator for what is it, for n? Anyone? Because then we can use the Rao-Blackwell theorem to tighten it. In the notes, I go into all sorts of elaborations on this, but let me cut it short here. And so, what are the random variables? Anybody? We are starting with x1, x2, etc., xn. So So let's just see what's the expected value of any one of them. Anybody? What is the expected value of x1? Just try it out and see. So how do you find it? It's going to be k multiplied by probability of x1 equal to k. K goes from 1 through n, but this is 1 over n. So 1 over n sigma k, k goes from 1 through n. This is the sum of 1 through k. What is that? Anybody? So that's going to be n multiplied by so you get this. Now you have any clue? What in terms of an unbiased estimator? Huh? So So if you're interested in n, this is a sloppy estimator, right? So by Rao-Blackwell theorem, expected value of hx given t equal to t is the best estimator. So let's just do it. So this is going to be sigma hk or let's just simplify it as much as possible. So this is going to be expected value of hx is here 2x1 minus 1 multiply condition on t x equal to t. So that's 2x expected value of did I write it correctly? Expected value of t, okay. What is the question? Remember, the expectation is on x, right? On x1, right? This expectation is on x1. So x1 goes from 1 through n. So 2k minus 1 condition on tx equal to t. Okay, yes? So let me call this to be the best estimator, t naught. So T naught will turn out to be summation. This is, you just have to do this. So a lot of, so this is probability of x1 equal to k and tx equal to t divided by probability of tx equal to t. So the denominator, we have it here. And so what is the summation go to all the way to? See, if the maximum is up to t, this goes up to where? Anybody? Yeah, look, given t equal to t, so this only goes up to t, right? Because maximum is given to be t. Now the big job is finding this conditional density function. So you have my notes, so I'm just going to copy from here and give you the...
Calculus in the previous part? We did this in the previous part, right?
We didn't do it because
Like,
there it was much simpler. First of all, it was x1 equal to 1, right?
but with k here is some number, right? Oh, okay.
Yeah, but remember, that's the problem with these things. It's just 1 plus 1 is not it. It just doesn't, I mean, my point is the problem needs to be done as is. We did something very close. So anyway, if you, the way to do this would be, let me just tell you the steps involved. So this, of course, you can write this as sigma 2k minus 1 multiplied by this probability of x1 equal to k. Then remember, tx is maximum, right? Maximum of x1, etc., etc. We went through this earlier. Max of max or t equal to t is the same as t less than or equal to t minus that, right? Intersection with anything will be the same. So this is, you can see t less than or equal to t minus probability of x1 equal to k, t less than or equal to t minus 1. Divided by probability of t less than or equal to t. The previous one was not this complicated. So this much is true, right? Previously, what was in the denominator? Same thing? Same, okay, fine. Let's see how, but you didn't have this summation. There, the good thing was, it was just probability of x. So this makes it a little more complicated. And if you copy the results, it's already here, right? So I didn't have to go through this probability of, this is probability of t less than or equal to t less than or equal to t. This is, so.
Because k is less than 2, so you can just remove the first part.
Yeah. That's what is, that's in the numerator. So what about the denominator? So at least the denominator, let's numerator. So the denominator is going to be this is the denominator, right? Because this part is t to the power n to the power n. This part is t minus 1 to the over n to the power n. Okay? Yes? And here, as he's saying, let me write what he's saying. This you can write as x1 equal to k. Look at here, k goes from 1 through t. So if x1 is k, then the x1 is k, then the maximum is less than t is the same as x2, etc., less than or equal to t. So this is the same as max of, so this is multiplied by probability of maximum of x2, etc., xn less than or equal to t. Same thing there, but this probability is, there are only n minus 1 terms, so this is t over n to the power n minus 1, right? And there will be a similar term here, so I hope, and that comes outside, I hope you see this one. And so what I said is true up to t minus 1. So this is true for k equal to 1 through t minus 1. And because if k is t, then this term doesn't contribute, right? So let me write down here. So when k equal to t, you only have contribution from here. This term, which would be minus probability of x1 equal to k maximum. If k is t, maximum less than or equal to maximum of x2, etc., xn less than or equal to t minus 1, that probability is 0 for the last term. So this is just this. Now you can put it together, and if you do all the addition, etc., which is done here, you can expand. This is easy to expand, right? So this term is going to be what? 2 goes outside, first term plus last term, and the number of terms, plus t minus 1, right? 1, huh? Minus, okay. Minus what? Very good. Then you have to simplify with the if you put all this together, so this will very similar, but not the flipped version. You can see the previous one, right? So I skipped some steps because it's there in the notes, but this will turn out to be the final answer. Sometimes I go through all, if you go through all the details, but and so this is the view, or the one with the, so expected value of this quantity is n, and its variance is the minimum among all unbiased estimators for n.